Hello students, good evening to all of you. So here I'm going to solve some of the problems of HC Verma worked out examples chapter 1. I'm starting with problem number 4 there. So problem number 4 कुछ इस तरह से है. Young's modulus of steel is given to us and उसका value दे के रखा है 19 into 10 raised to power 10 Newton per meter square. Newton per meter square is the unit of Young's modulus. We have to express this in dyne per centimeter square. So ये जो dyne है, this is the CGS unit of force and you all know that centimeter is the CGS unit of distance there. So we have to express this term in terms of dyne per centimeter square. Students, 1 Newton is basically equal to 10 raised to power 5 dynes there. So first we convert that. So it is like 19 into 10 raised to power 10 and then we have Newton. So 1 Newton is equal to 10 raised to power 5 dyne. So हमने Newton को convert कर दिया dyne में and then in the denominator we have Newton per meter square. We have meter square there. So 1 meter means 100 centimeter there. So it is like 100 centimeter square there. सो इसे हम लोग सॉल्व करेंगे. इट इज़ लाइक 19 इंटू 10 रेज टू पावर 10 हमारे पास ऑलरेडी है एंड 10 रेज टू पावर 5 100 मीन्स 10 रेज टू पावर 4 देयर. सो ये यहाँ से कैंसिल हो जाएंगे 4 एंड वी आर लेफ्ट विद 19 इंटू 10 रेज टू पावर 11 बिकॉज एक यहाँ से आएगा 10 एंड 10 ऑलरेडी है डाइन पर सेंटीमीटर स्क्वायर. सो दिस इज द कन्वर्जन ऑफ दिस Young's modulus of steel from this system of unit to dyne per centimeter square. So now let's come to the problem number 5 there. In the problem number 5 we have if velocity, time and force were chosen as the basic units, like as you all know that basic units means fundamental units हम जानते हैं force, mass, length, time, these are the fundamental or the basic units. But in this problem we have selected velocity, time and force as our fundamental or basic units. So if these are the basic units then we have to express the dimension formula for mass. So students, it's quite easy, quite fast हम इसे कर सकते हैं. We know that force is equal to mass multiplied by acceleration. So force is equal to mass and acceleration we know that it is simply change in velocity upon time. मतलब हम simply write कर सकते हैं velocity upon time there. So from here we can get the answer for our mass. Like mass is force multiplied by time upon velocity. Simply like there is some cross multiplication there. So mass is force into time upon velocity. So this force, time and velocity are our fundamental units or basic units there. So force के लिए we write F and T के लिए T, time के लिए T and velocity के लिए like V. But it is in denominator so it is written as V inverse. So यहाँ से जो mass का dimensional formula बन रहा है this is F T V minus 1. So this is the answer for this question. इस तरह से आप mass को express कर सकते हैं, उसका dimension formula write कर सकते हैं in terms of F, T and V. Because now these are the fundamental units in this problem. Now let's come to the next question, question number 6 there. We have to check dimensionally that this relation is correct or not. So like V square U square, you all know that this is like V square minus U square is equal to 2AS. This is one of the equation of motion there. So this relation is basically correct if the dimensional formula for each term in the LHS and RHS is same. So velocity, this is velocity, it is simply LT minus 1. So it is like LT minus 1 square there. This is also velocity, initial velocity. So it is also LT minus 1 ka square. And if this x is a distance, so we can write it as 2 is a constant there, dimensionless constant. So acceleration का जो formula है, it is LT minus 2. And students, यहाँ से like this is x. If this x is a distance, then we write L for that x there. So left hand side में जो formula बन रहा है, it is L square T minus 2 and in the right hand side it is simply L square T minus 2 because यहाँ square है plus L square T minus 2 means this is some like velocity square and this is also velocity square and this term is also velocity square means we are adding velocity square with the velocity square there. So like यहाँ पर हर एक term का जो dimension formula है each term on the either sides of equation are same. So it means that this relation is a correct relation. So I just hope आपको ये 3 प्रॉब्लम समझ आए होंगे. With that, thank you.